A 3.8 millimeter wide beam of 32.7 nanometer light illuminates 1,112 slits in a diffraction grating. What is the smallest difference in wavelength from this wavelength that the grating can resolve in the second order? So that's by the way this delta lambda, right? How many slits per centimeter does this grating have? All right, let's do A first in the interest of coherence and sanity. Okay, so our wavelength is 432.7, and we're trying to solve for the resolution. How far away from it can it be, and we could still resolve these spectral lines. Okay, because when you look at a spectrum, there's going to be these little lines. And some of them are really close to each other, and the question is, can you tell that it's two lines or one line? That's what we're doing here. Okay. And that's going to be, which order are we doing it in? Second order. Okay. So M is going to be 2. That's our wavelength is this, right? Okay, so we're going to go second order, and then it's 1,112. And then we can solve for that lambda, right? So I'm going to go 432.7, and basically just divide by this and you'll get this, right? So divided by 2 divided by 1112. And I get that delta lambda is equal to 0.19455, so 0.195 nanometers. Okay. Notice I put nanometers in here, and so this will come out as nanometers, which is just fine. That's what you want. Okay. So what is the smallest difference in wavelength? Okay, so we've got that. All right, how many slits per centimeter does this grating have? Well, if 3.8 millimeters is that many slits, then I don't know. Let's see. I think we got to do like a proportion. Let's see. Oh, well, there are two ways to do this, right? So we can go 0.380 centimeters is to 1,112. As 1 is to x, right? You can just do a simple proportion, right? Because it's saying how many slits per centimeter, right? This 3.8 millimeters is 0.38 centimeters, and they're asking you if you had a whole centimeter, what would it be, right? So you could just do a direct proportion like this. I'll show you another way to do this, by the way. Okay, but let's go with this, because this is pretty cool. I like proportions. So I'm going to go this times this divided by this, and I'll get that. So 1112 times 1 divided by 0.38 is equal to x is 2926.3 lines per centimeter. Okay, or 2930 lines per centimeter if you have 3 sig figs, right? Now I know you didn't like that, okay? Because it's like a proportion and it's like, whoa, but I love proportions. Well, let me show you how to do it if you didn't want to do proportions, okay? So what we can do is we can figure out D. D is going to be 3.8 millimeters, so 3.8 times 10 to the minus third divided by 1112, right? So 3.8 millimeters is that many slits. So let's figure out the distance separating the slits. 3.8 times 10 to the minus third divided by 1112. And that is the distance separating the slits is 3.417 times 10 to the minus 6 meters, right? So then the question is how many slits per centimeter? That's going to be 0.01 meters divided by 3. So how many of those fit into 0.01, right? 3.417 10 to the minus 6. So I'm going to go 0.01 divided by the answer I just got. And you know what I just got? I got 2926.3 lines in 1 centimeter, which is what they're asking. Okay. Yeah.